Hey guys, so today we're looking at 9.4 day 1 for Algebra 2, and I know we've done this chapter out of order a little bit, but it's intentionally designed this way. All right, I think this is the best way to present the problem, because we're saving graphing for last, and I know that you all just hate graphing, and so, may as well throw that at the end and not right at the beginning to demoralize you all. So, day 1 of 9.4 is talking about adding and subtracting fractions. That's the gist of it, right? And make sure when you're writing down notes that you don't have to write down all this stuff because we'll get to it all, right? You should write down that we're doing 9.4 day 1, and then maybe the title if you're interested in being able to refer back to it later. Now, here's the list of things we're going to be doing: adding, subtracting rationals, or like fractions with common denominators, adding and subtracting rationals where one fraction has to be multiplied or manipulated, and then where both fractions need to be manipulated. And I'll talk about what this means as we go forward, because that's what we're doing today. And then on the next lesson, we will do a lot more complicated things. Now, this stuff, feel free to not write. All right? This is just sit back and listen and pay attention and make sure that you can understand the concept, because math is all about concepts, right? If you understand the concept, you can apply it to any problem. If you understand how to do one problem, but you don't know how to do the concept associated with it, you're not going to know how to do any other problem, like the ones I would give you on a quiz or a test or that you'd see anywhere else. So you need to understand the concept. So the concept at play here is that if you have the same thing in the denominator, you add these fractions in a particular way. And the idea is that if you have 4/5 plus 3/5, how many fifths do you have? It's like if you have 4 apples and 3 apples, how many apples do you have? The apples is like a grouping. It's like a label, just like fifths are like a label. And so if you have 4 of them and then you have 3 of them, well, now you have 7/5. Right? This is the idea, that it doesn't matter what category these belong to, so long as they're the same category, you just add how many of them you have, which happens to be the numerator's quantity. So you would just take the top plus the top, and you'd leave the bottom the same. A lot of students think that, I add across the top, let's add across the bottom, but that's not how it works, because the concept is not where you're just adding things willy-nilly. There's an idea behind it. It's 4 of like an idea of fifths. So the same exact concept can apply here, where you've got 4 over x, or like 4. Imagine x is like fifths, right? Where it's like their own category. If you have 4 of them plus 3 of them, you have 7 of them, which looks just like this. It's the same exact concept. It's just sort of hard to say out loud, because we can say 4/5 we got words to that, right? But we don't have one of those words for x's. It's like we got 4x, right? Plus 3x. Yeah, it's not working out. So, but the idea is exactly the same. So you need to keep this in mind when you're working with fractions, all right? Keep the denominator, add across the numerator. That's right. So with that being said, let's start getting into stuff that might look a little more foreign to us, right? So we've got x plus 6 and x plus 6 as our denominators. Now, remember, if you're thinking about the denominator as categories, right, then these are the same, which means that the numerators are just amounts that we have of the quantity, of this quantity down here. And so if we have x of these, and then we have 7 of these, then we have x plus 7 of these. You add across the numerator. We don't know what x is, but that's fine. It's the concept that's important. It's the idea that even though you might not know what x is, or you might not know here what x is, the idea is exactly the same. That when you're adding fractions, you consider it like 4/5, like 4 apples, right? I always like to use apple because, it's just the way, the thing I was taught. So this would be x plus 7 of this category here, this quantity, which is x plus 6. And that's it, you're done. No more stuff to do. And we were able to do this, keep in mind the idea here. We were able to do this Because they shared a common denominator. They were in the same category to begin with, and so when we could combine them, they were still in that category. All right, so let's move on. This next thing we're doing is another problem just like this. I would like for you to attempt this problem and let me know. Actually, I'm a video person, right? So you can't let me know, but work it out, and I will finish it right after that. So pause the video, work it out. Give me just 1 second. Man, sorry, allergies are getting to me, and it's a problem. So if you look here, we have x minus 3 in the denominator. So all we need to do is combine the numerators, because if we have this many x minus 3's and this many x minus 3's, we're just taking these minus these. Like, these aren't adding, we're subtracting here. But imagine, imagine that these are like apples, right? I can't draw an apple very well, but we'll see if I can give it a go. Let's see here. Why am I wasting your time with this? That's not an apple. This this device I'm writing on is like really expensive, and it's meant for artists. And every time I look at it, I'm like, man, if only I was an artist, I would be able to make such good use out of this like $850 device or whatever this costs now. But no, I'm terrible at it. Anyway, that aside, I try to not sidetrack myself during lesson videos. This is what you would get before you simplify. And the concept is what's important. You need to understand the concept, because that's how you get from problem to problem, is by is by using the concept. So the idea here is that since we have the common denominator here, you want to combine just across the numerator. And so it would be this amount minus this amount. And so that's all I've written. I've written this here, and then minus, and then this here. But the important thing is the parentheses, because these parentheses need to be distributed, or these the negative needs to be distributed. And so you will end up with x squared minus 4 minus 2x plus 1. So the distribute makes it negative 2x, distribute makes it positive 1, over x minus 3. And now you just combine like terms on the numerator. So like terms, as just a refresher, are variables with the same exponents are like terms. So this is x squareds, so those are only like terms with other x squareds. Here's our x's, so they're only like terms with other x's, and then this is like without x's. And so these are like terms with everything that's not an x. So we've got x squared because we are just carrying over everything. So x squared doesn't combine with anything, so we get x squared. And then the minus 2x does not combine with anything. And then the minus 4 and the plus 1 makes minus 3 over x minus 3. And we are still not done, because we have simplified the fraction as much as it can go for now. But this is where 9.3 comes in. This numerator here, what do I want to highlight it in? How about blue? This numerator here can simplify further by factoring. You think, how can I factor this quadratic? This is what we just quizzed over. And if you did poorly on this quiz, I got some troubling news for you. This is only going to get harder, so you need to buckle down or stop being so lazy. That's probably the more correct thing. If you want to be real with you guys, it's laziness, just pure laziness. So we want to factor this, and we should already know how to do this. You want to think what multiplies to give negative 3, adds to give negative 2, and that would be negative 3 and positive 1. So it'd be x minus 3 and x plus 1. And if you notice, what this turns into is x minus 3, x plus 1, over x minus 3. And the x minus 3's cancel, and you're only left with x plus 1. Now, when we get to graphing, there are some problems with like a function like this, and we'll get to that later, but it does simplify to x plus 1. So I'll just leave it at that. Now, we're moving on to the next idea, which is what you can do when you don't have a common denominator, when you can't simply just add across the top or subtract across the top. Now, you don't have to write all this down right here on the side. If you're taking notes and you want to be a good note taker, then write this down, write the example down, and then as I work through this, maybe draw arrows to things, sort of make little notes. That's how you take good notes. They're for yourself. Notice that we have a denominator of x plus 2, right? That's right here. Easy to see. In order to add these things together, right, like I was talking about, the same category, this 4 is not currently in the same category as this, so we cannot combine them. So we need to make them in the same category. And how we do that is by multiplying by a form of 1. Because that is what you do to manipulate single terms. You guys were probably taught, like, if I've got x plus 2 and then 3 over here, I can't just subtract 2 from this side and just call it good. It's not just 3 equals x. You were probably taught what you do to one side, you have to do to the other. And by side, I mean side of the equal sign, right? What you do to one side of the equal sign, you must do to the other to balance things out. But what if you don't have an equal sign? Like in this situation, we don't have an equal sign. So it's not like we can just subtract 2. We can't do random things or things to just one piece. We don't have an equal sign. We don't have that liberty. What we are allowed to do instead is multiply by a form of 1. Because, 4 times 1 is still 4. It doesn't actually change the problem, which is the key component here. If you change the problem, then you're not working the problem anymore. You're working a different problem. So you have to do something that doesn't change the problem, but changes how it looks. So what we're going to do is we're going to multiply by a form of 1 that will make it have x plus 2 in the denominator. And we multiply by x plus 2 over x plus 2. Because I'm sure you guys can recall that anything divided by itself, excluding 0, gives you 1. Right? Like 4 over 4 is 1, and 10 over 10 is 1, and x over x is 1. Right? It's the same concept. Anything over itself is 1. And like I said earlier, we're allowed to multiply single terms by forms of 1 because it doesn't actually change anything. It just makes it look different. So let's do that. We're going to multiply the 4 by x plus 2 over x plus 2. And here's another important piece of information to remember, is that all whole numbers are secretly over 1. And so, to multiply fractions, we covered this on the review day, you just multiply straight across. So when you multiply straight across, you would get 4, and then you'd be multiplying x plus 2, that's supposed to be an x, plus 2 over x plus 2. And so this is what we have. The 3 over x plus 2 carries over, and then the 4 over 1 multiplies, and I'm not combining anything quite yet. Sometimes you might not want to. But this is how I would get a common denominator now. Notice that we both of our fractions now have x plus 2 in the denominator. Because when you multiply straight across, you multiply 4 times the top, 1 times the bottom. Well, 1 doesn't change anything, and so that's all it is. Now, since we have a common denominator, all you do is the same thing we did above. You just combine the numerators. And so you're going to have 3 plus this, all over x plus 2. And that is not a pen. 3 plus this over x plus 2. So if you're just saying find a common denominator and combine, then you're done. If you want to simplify, then you can. You'd have to distribute the 4, and you'd get 3 plus 4x plus 8 over x plus 2. And then you combine like terms some more. And sorry, I was zoning out there. It would get me off topic if I start talking about it. So 8 plus 3 is 11, and I have to stay on topic because my students complain at me when I'm not on topic. And if it's one thing I hate, it's my students complaining at me. So, here we go. There is our answer. Notice that the 4x plus 11 cannot reduce, it cannot factor, so we are done. So, if you think you understand the concept, then try to apply it here, where you're trying to multiply this piece by a form of 1 that will create a denominator of x minus 1. Try to think about the problem, right? Think. Actually start trying to use that thing that is between your ears. So, the idea is that you want to multiply by a form of 1 to obtain the denominator of x minus 1. And to do that, you just multiply by the form of 1 that is x minus 1 over x minus 1. Because that is dividing by itself, which is totally fine. I can multiply single terms by forms of 1 and not have a problem. And what we end up with, I'll just write it out here. Remember, anything that doesn't look like a fraction is secretly over 1 times x minus 1 over x minus 1 minus x plus 7 over x minus 1. Now here, when you're multiplying fractions, you multiply straight across. And so you will get 5x times x minus 1 over x minus 1 minus x plus 7 over x minus 1. Now we have a common denominator, and so we do the same thing we did earlier. You just to do the top and keep the bottom the same. So you take the top minus the top, and so you're going to have 5x times x minus 1 minus x plus 7. This, as you might be able to imagine, is the most common mistake. They forget the parentheses when they're subtracting. Divide by x minus 1, and then we continue the problem. You're going to distribute the 5x, distribute the negative, and you're going to get 5x squared minus 5x. We're just multiplying. This times this times this. And then we're going to multiply the negative through, and so you're going to distribute it. And this is all over x minus 1. And next, you combine like terms. And as I was saying earlier, the squareds are like terms, the x's by themselves are like terms, or the x's to the first power rather, and the numbers are like terms. And so we're going to have 5x squared minus 6x minus 7 over x minus 1. Then we might want to investigate, is this factorable? Because if it's factorable, then we want to factor it. And if it's not factorable, then we can move on with our lives. And you would have to factor this using slide and divide because there's a 5 in the front. And so let's slide it over and see what happens. So you'd have x squared minus 6x minus 5 times 7, which is 42. Then we think, is there two numbers that multiply to give us negative 42 and add to give us negative 6? 42. Well, you got, if you're having trouble with this, well, you got 1 and 42. You got 2 and 21. 3, I think goes into it. 3, and then 12, 4, 14. And then 4 doesn't go into it. 5 doesn't go into it. 6 go into it? 6 times, what? Interesting. Interesting. I now see that I am stupid. Wow. I often say this, but, and I mean, this is a one take, right? I'm not editing this. I'm not going to make myself look any less stupid. 5 times 7. I was thinking to myself, something just doesn't feel right here. And then it turns out, of course, because 5 times 7 isn't 42. Well, we all make dumb mistakes here and there. Wow. This is 35. Wow. This is, it would be embarrassing if I cared too much about it. But I guess this is just entertaining for you guys. Trust me, I can do like differential calculus. I can do all sorts of things, but 5 times 7, way too hard for me. Um, yeah, the more I multiply, no, the more I do of like higher level math, less mental math, the less mental math I know. Who'd have figured? Who'd have thought it? That's unbelievable to me. All right. Anyway, regardless, now this is useless for now. So now we got to figure out factors of 35. Well, that's easier. 1 and 35, 2 and nothing, 3 and nothing, 4 and nothing, 5 and this, 6 and nothing, 7. No, we're not getting there. Man, what would really be funny is if 5 times 7 wasn't negative 35. Man, that would be the craziest. I would really actually feel stupid in that case, but I'm pretty sure we're right? Because like 5 times 5 is 25, and then 5 times 6 would be 30, and then 5 times 7 would be 35. Man, that's funny. Whatever. I'm stupid. That's okay. I'm stupid sometimes, all right? I'm stupid sometimes. That was a waste of a couple minutes. So we're done with that because it can't factor. Now, you should write all of this down. We are moving on to simplifying when both of the denominators are different, when it's not just one that needs to be changed, but both need to be changed. And so I'm going to start referring to these terms as pieces. And I'll say something like, this is the left piece because it is the left term, and this is the right piece because this is the right term. And so that's what I'll be using the word piece a bunch, okay? The whole idea behind this is sharing is caring. That's what my mother used to always say to me, but then she'd laugh afterwards. So sharing is caring, and so I can never take her seriously. Was she serious? What does this mean? I don't understand. I was a child. Now I understand that sharing sucks, and that's why she was laughing. But anyway, so sharing is what you need to do to make these denominators have the same value. So notice the left piece has an x in the denominator, and the right piece has an x minus 1. They need to share their denominators. The right piece will need an x, and the left piece will need an x minus 1. So we're going to work through this and share these denominators. And once you get the hang of this, it's actually pretty simple. So you might think to yourself, well, Mr. Dybel, are you blind and stupid like you were previously? I clearly see an x here. And I would say, fair point. I didn't know 5 times 7, and I got it wrong. But I'm certain about this because remember, pieces of products are what must be canceled. This entire thing is considered one piece of this is one denominator. It's not two separate pieces. This is one thing, and this is one thing. And so you can't just say that this has an x already because it doesn't. It's not considered its own separate thing. It's combined with the minus 1. Now, anyway, back to the sharing. This left side, the left piece, needs an x minus 1. So let's go ahead and give it an x minus 1. Just like that. You multiply by x minus 1 over x minus 1. Then the right side needs an x, and so you just multiply by x over x. If you had more terms, you just keep doing this. So now we just multiply each of these. So I'm going to box what we need to multiply. You need to multiply these together, and then you need to multiply these together. And so you get 3 times x minus 1. And the denominator is x times x minus 1. Don't simplify the denominators. You never want to do that. Plus 2x times x, which I'll simplify in a minute, over x times x minus 1. And now you might be thinking to yourself, man, this is looking so complicated. But remember the concept. You are just trying to multiply by forms of 1 that get you to share your denominators. Now we have a common denominator. Here is our common denominator. We have shared, and we are now happy that we have a common denominator. And so all you need to do is multiply, not multiply, combine across the top. So we'd have to distribute that, and then we have to add. So I'll distribute 3x minus 3, and then plus the 2x times x, which is 2x squared, over x times x minus 1. This is already in its simplest form. And after thinking in my head, this won't factor using slide and divide. All right, I need to, flex my brain nowadays. And man, I need to learn my times table again, basically. So this is it. You can't go anywhere more than this. This is as far as you can go. All right, let's move on to the last couple of examples that we've done. I know it's taken quite a while, but we're not done yet. I'm moving as fast as I can. Okay, so let's see here. So here's our third to last. We have 3 more examples left. So this is, 3 more. So I'll run through this with you. Again, write down the problem, pause the video if you need a second, write down the problem. I'm going to start explaining it. I want you to look at the denominators. We've got x plus 1 here and x minus 5 here. They're both separate denominators. And sharing is caring for denominators. And so this piece over here needs an x plus 1. So we need to give it the x plus 1. Then this piece over here needs an x minus 5. And so we want to give it an x minus 5. And now you multiply across the top on each separate fraction. Work with each fraction separately. So you have 2x times x minus 5 over x plus 1 times x minus 5. I'm not combining the denominators ever. And we have 5 times x plus 1 over, and I forgot to write my 1 because I am stupid, x plus 1 times x minus 5. That's why it doesn't really bother me when my students insult me, even if they're really nasty about it, because I insult myself all the time, man. I call myself stupid and an idiot just constantly. I tell you, when I'm at home and I'm playing video games and I'm just making mistakes, I am chewing myself out loud in my room. Here, you've got 2x times x, which is 2x squared, and then 2x times negative 5, which is negative 10x. Then we have plus, so we don't have to worry about parentheses, 5 times x, which is 5x, and then 5 times 1, which is 5. And the denominator stays x plus 1, x minus 5. Remember, when you have a common denominator, which we do here, you don't need to move anything in the denominator. You just add across the top, or subtract if there's a subtraction sign here. And now we combine like terms. The x's here can combine. These ones can combine. And so you'd have 2x squared minus 5x plus 10. 10? What am I, stupid? Don't answer that. Plus 5 over x plus 1 times x minus 5. 2x squared minus 5x plus 5. Yep. Seems good to me. Moving on. See if this is factorable. Well, there's no common factor, so we can't factor or get a common factor out. I know I said factor a lot. Then you'd have to slide and divide. So 2 times 5 is 10. Well, 10 doesn't have any factor pairs that can add to be negative 5, so we're done. Moving on. You guys should be able to, at this point, work this problem out. Try to do this. I'm going to go ahead and work it out as well. What is even happening? Man. This is why I should never record videos at 9:33 p.m. Because my brain starts to atrophy. And you guys definitely don't want me teaching you when my brain is mush. But, you know, I'm sad to say, but you don't have much of a choice. At least right now, I'm your teacher, and that's all there is to it. You just have to deal with it. So, I mean, not that that's a bad thing. You guys should be happy to have me as a teacher. Jeez. I'm going to go ahead and FOIL, distribute, 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 and I'd get x squared plus x plus 2x plus 1. And then I'll go ahead and keep this separate for now. And this will be 4x squared. Doing okay so far. And now we want to combine and then subtract. So this is actually x squared plus 3x plus 1 because these two combine. And then we're going to subtract this. So you've got x squared plus 3x plus 1 minus 4x squared all over x times x plus 2. And now we combine like terms. So moving on straight through here, we got the negative 4x squared and the positive 1x squared makes a negative 3x squared. And then we've got plus 3x plus 1 over x times x plus 2. Then is this factorable? 3? No, it's not factorable. So we're done. Can't simplify anymore. Last example. Oh my gosh. If you are following along, this is great. I know this is a long lesson, but sorry, I can't help it. Again, our main idea here, we are sharing denominators. This piece over here has the x plus 5, so this piece needs an x plus 5. This piece has a 2x minus 1, so this piece needs a 2x minus 1. That's the idea. So I'm multiplying by this side and multiplying by this side. So you're going to get 5x times 2x minus 1. If I can write numbers and stuff. Typically by now I'm starting to like wind down and start to relax before going to sleep. I'm not as much as I tell you guys I play video games and I play them all the time and yada yada yada. I don't have like a teenager video game lifestyle, put it that way. I go to bed like early. And the reason I'm prattling on about nothing is because I'm doing work. So now I'm going to start distributing, and 5x times 2x is 10x squared, and then 5x times negative 1 is negative 5x. And we'll keep this here, and then x times x is x squared, x times 5 is 5x, 1 times x is x, and 1 times 5 is 5. The denominators will stay the same. I'm just going to go ahead and do this. How about this, guys? This denominator here, it's a cool denominator, I know, but that's what's going to go here, all right? Now, moving right along, this top can simplify by combining like terms, just like this. Okay, the 5x and the x make 6x. Then it's going to be this top piece minus this piece, because they have a common denominator, so we're just going to combine the tops and keep the bottom. 10x squared minus 5x minus x squared plus 6x plus 5, all over this denominator, which is going to equal, now we have to distribute the negative sign in. I know this is a lot of work, guys, but the more you complain about it, the longer it's going to take you to do. Every moment you spend complaining about the length of the problem is another moment you're not doing the problem. I tell my calculus students that sometimes. So, this is over 2x minus 1 times x plus 5. And so we combine the numerator by combining like terms. So 10x squared minus 1x squared is 9x squared. And then minus 5x minus 6x is minus 11x minus 5. Now, is this factorable? It might be. 9 times 5 is 45. That's one I've got down. It's my 7s and my 6s and my 8s, man. They're no bueno. I'm really bad at them, actually. Particularly, well, no, all of them. I'm bad at all of those. 45. Factors of 45. 1, 45, 2, nothing. 3, nothing. 4, nothing. 5, 9. 6, nothing. 7, nothing. 7, nothing. 8, nothing. 9, 5. No, we're done. So nothing, no factors. So it's the final answer is going to be this divided by 2x minus 1 over x plus 5. Wow. It was a long, arduous journey, but we made it there. Your homework is going to be a worksheet, and it's going to be on the table for you to pick up. You know, assuming there is a table. You know, this is if this is watched in the future, I'll have already addressed what you do when you see homework. So. Yeah, there you go. That was that. 36 minutes? Jeebus. Jeebus Louibus. All right, so I imagine that those of you who were struggling with 9.3 because you refused to do problems on your own and actually learn the content are really going to start struggling here. So please, for the love of everything that is anything, do your homework. Do it alone. Don't cheat. I tell you these things, and you just completely ignore me. It's difficult to teach someone who literally cheats on everything you can, never does any of their work. How do you, think if you were the teacher, how you would teach someone like that? Man, I know I complain about this a lot, but it's a real problem. Maybe it's just this school. Maybe not. Who knows? Whatever. You guys have probably already stopped the video by now. I could start ranting about whatever I wanted to, and nobody would hear this. Man, I should start ranting about all sorts of things.